In this video, we'll look at exponent laws. Some of them will be review, but we'll also get into some negative and zero exponents a little bit. So let's start with reviewing some basics. So when we multiply powers with the same base, so just a reminder, this whole thing here is called a power. There we go. The 2 is the base, and the 3 is called the exponent. And when we multiply these powers together, let's look at this the long way. Well, 2 cubed just means 2 multiplied by itself 3 times. So 2 cubed would look kind of like this. That's our 2 cubed. And then we are going to multiply that by, let's try that again. So we'll multiply that by 2 squared. Well, 2 squared means 2 times 2. Again, here's our 2 squared. So maybe we'll include that down here, 2 squared. And this one here is 2 cubed. So if we want to simplify this, again, we have 2 multiplied together a whole bunch of times, and if we count them up, we can see that there are 5 2's there. So this really ends up being 2 to the 5. Now, obviously, we don't want to have to rewrite this every single time we do this. So when we multiply powers with the same base, the shortcut here is to say, hey, let's take that base, keep the base, and then just add the exponents. And the reason why that works is that we're multiplying 2 by itself 3 times and also 2 by itself 2 times. So in total, we're multiplying 2 by itself 5 times. And then if we wanted to evaluate this, we could go to our calculators and plug that in and get an answer of 32. And so generally, the rule here is that if we have powers with the same base, and it is important that the bases are the same, so to multiply powers with the same base, powers with the same base, basically we keep the base and add the exponents. And we'll kind of write that out. Keep the base. And we also add the exponents. So I'll just add that over here. Oh, sorry about that. And sort of concise mathematical way to write this would be using something along the lines here. We have a to the m times a to the n. So 2 powers with the same base, we're multiplying them together. We keep that base and add the exponents. So that is how we multiply powers with the same base. Dividing is similar. You might be able to kind of figure out how this is going to play out. Again, I'm going to start by writing this out the long way. 2 cubed means 2 times 2 times 2. And we are dividing that by 2 squared. And you can see here, if we go through this process, we should be able to divide out a 2 from the numerator. 2 divided by 2 is just 1. Well, that's a bit thick. Let's try that again. Let's see if we can fix that up a bit. There we go. So 2 divided by 2 is 1, and we could do that again. 2 divided by 2 is also 1, and that leaves us here with just 2. Let's fix that up. So equals just 2. I'm going to write it as 2 to the 1 just so we can make the connection here. And so really what we did is we had 2 multiplied by itself 3 times, and then we were dividing out 2 squared. And so we ended up with just 2 to the power of 3 minus 2. So similarly to what we had before, when we're dividing powers with the same base, we keep the base and subtract the exponents. Keep the base and subtract the exponents. And again, if you wanted to, you could write a statement similar to this one to divide powers with the same base, keep the base, and subtract the exponents. So that's how we can divide powers with the same base and multiply the powers with the same base. Let's keep going here. Powers of powers, again, we'll start with the basics. 2 cubed squared means take 2 cubed and square that. So when we square this, we're going to get another copy of it. So that's going to look like this, 2 times 2 times 2. There's our first copy, and then we multiply that by itself. 2 times 2 times 2. And that will give us, again, we're just multiplying a whole bunch of 2's. In fact, we are multiplying 6 2's together. And so notice here that the rule for powers of powers, if we just multiply those two things together. So if we have powers of powers, so exponents to exponents, the rule is keep the base and multiply the exponent. So generally speaking, a to the m to the n is equal to a to the m times n. And again, if you forget any of these rules, you can always just go right back to the basics. What does it mean to have a power to a power? So often, especially in this example, for whatever reason, students would kind of mess up and they would think, oh, 3 plus 2 is 5. But again, go back to what does it mean to do 2 cubed squared? Well, it means to take 2 cubed and multiply it by itself. So you can kind of build this scenario here and see what's going on. All right, let's move into some zero exponents, and then we'll get to some negative exponents. So 3 to the 5 divided by 3 to the 5. When we take a number and divide it by itself, we get an answer of 1, which I think is pretty straightforward. However, I'm going to write this out the long way, just like we did before. So 3 to the 5. Probably could have chosen something a little bit smaller, but you'll get the idea here. 1, 2, 3, 4, 5. There's 3 to the 5 divided by 3 to the 5. And just like we did with the division example, we can actually divide out, instead of 3's, and get 1. So 3 divided by 3 is 1, 3 divided by 3 is 1, 3 divided by 3 is 1, and so on. So that's pretty obvious why that works. As I said, we could have just done that right from the 3 to the 5. So this is equal to 1. But using what we know about the rule for dividing powers with the same base, we have this other option here as well. So, or 3 to the 5 divided by 3 to the 5, because we're dividing powers with the same base, that should be the same as keeping the base and subtracting the two exponents. Well, 5 minus 5 is 0. Let's try that again. Sorry about that. So 5 minus 5, as we said, 5 minus 5 is equal to 0. Well, if 3 to the 5 divided by 3 to the 5 is equal to 1, but it's also equal to 3 to the 0, that means that 3 to the 0 is equal to 1. And in fact, any number, almost any number, I should say, there's one exception that I can think of, almost any number to the 0 is equal to 1. The one exception, in case you're wondering, is that a cannot be 0. If we have 0 to the power of 0, we call that an indeterminate form. So a to the 0 is equal to 1, so long as a does not equal 0. So nice and easy in terms of what do the zero exponents mean. Now let's get into some negative exponents, because that's where things get a little more challenging. Again, I'm going to start this the same way that we did before. 3 cubed means 3 multiplied by itself 3 times. And 3 to the 5 means 3 multiplied by itself 5 times. We can do the same process that we did a while ago, where we divide out. 3 divided by 3 is 1, 3 divided by 3 is 1, 3 divided by 3 is 1. So in the numerator then, we are left with 1. And in the denominator, we're left with 3 squared. Now obviously we could square the 3 and get 9 and evaluate this, but I want to leave it like this so we can make the connection. So this is one option. The other option is to use that rule for dividing powers with the same base. The rule here said that if we have two powers with the same base and we're dividing those two powers, we keep the base and we subtract the exponents. 3 minus 5 is -2. So again, we have a scenario where we have two answers, and those two answers have to be equivalent because we basically started with the same question. This means, a little bit too far there. This means that 3 to the -2 is equal to 1 over 3 squared. And I hope now that you can see why I didn't actually square the 3 so we can make that connection. So generally speaking, if we have a negative exponent, we can take that exponent, that power, we can just take this whole power and put it in the denominator and the exponent becomes positive. So generally speaking, any power to a negative exponent, we'll write this two different ways. That's too big, let's fix that up. Any power to a negative exponent, a to the negative m, say, is equal to 1 over a to the m. You might wonder, why would we do this? What's the point? Well, I don't know what 3 to the -2 is, but I can figure this part out. I can figure out what 1 over 3 squared is. So 1 over 3 squared is the same as 1 over 9. So that means that 3 to the -2 is equal to 1/9, and we were able to do that because we were able to rewrite our negative exponent as a positive exponent by taking the entire power and moving it from the numerator to the denominator. The flip side is also true, is that if we have 1 over a to the -m, so if we have our negative exponent in the denominator, and for the same reason that we did earlier, we can take that whole power from the denominator and move it into the numerator, and that causes the exponent to be negative. Maybe we should do an example just so you can see what that looks like. So here's an example. And the question here, let's just talk about rewriting. Maybe rewrite as a positive exponent. Or with a positive exponent is probably a better way to say that. With a positive exponent. And we'll do two examples so you can see how this works. So here's our first one. Let's try 5 to the -2. So again, we have this exponent that's negative. We can then take the whole power, so this whole thing over here, that's whole power, and move it from the numerator to the denominator. And you might be saying, well, there is no denominator, but we can just create a denominator and put a 1 in the numerator. So we take this whole thing, move it down into the denominator, and then what's left in the numerator is just a 1. Now you might be wondering, what happens if there are multiple powers here? So let's do 4 to the -3 times 3 squared. And in this case, we have one power with a negative exponent and the other with a positive exponent. We'll leave the one with a positive exponent in the numerator. And actually, before we get to this, some students find it tempting to want to combine these two. But again, remember our rule on the first page for multiplying powers. They had to have the same base. And if they have the same base, we keep the base and add the exponents. These two do not have the same base, so we can't multiply these powers at all. We have to keep them separate. So there's our 3 squared. It's going to stay there, and we'll take that 4 to the -3 and move the whole thing into the denominator. So we get 4 to the -3 there. Sorry, when we move it to the denominator, the exponent becomes positive. So it was 4 to the -3. We moved from here down into the denominator. So the exponent, and only the exponent, it's not the base, it's just the exponent that becomes positive. Let's do one more. Let's do one where the negative exponent is in the denominator. And let's be a little bit more abstract here. Let's talk about a squared divided by, let's do let's not use the same variable. Let's use b to the negative 5. So again, the a's and the b's are different. We can't divide these by just subtracting the exponents because the bases have to be the same in order to do that. So remember, our rule for dividing was that if the bases are the same, we keep the base and subtract the exponents. They're not the same here, but we can take this power that has a negative exponent and move it from the denominator into the numerator, and that will give us a positive exponent. So we'll get a squared, that doesn't change, and b to the 5. Now you might be wondering what happens if they're both negative. Let's do one of those. A power in the numerator that's negative and one in the denominator that's negative. Let's do 4 to the negative 2 divided by, let's go 7, say, to the negative 3. So first off, we want to take this power and change it to a positive exponent. So it's going to move from the numerator into the denominator. And our negative exponent in the denominator is going to go from this direction up into the numerator, and that will give us a positive exponent. So we take that whole power, move it into the numerator, and the exponent's positive. Again, we can't do anything with the 7 and the 4. They're different bases, so we just leave it like that. If the question had said to evaluate, we could go ahead and figure out what 7 cubed is, what 4 squared, and go from there. But it just said to rewrite as a positive exponent. We already talked about this, negative exponents in the denominator. Again, just as a reminder, there's the whole power. The exponent is negative. We're just going to move that from the denominator into the numerator. So we get 2 cubed. I want to look at a table as a way to see how these negative exponents work, because sometimes I find that students forget the rules, and that's okay to forget the rules. We all forget some things sometimes. So I want to have a look at some examples here. So in this table I have x, and I have this function p of x, which is equal to 2 to the x. So really what we're doing is we're subbing in the x values. When x equals 0, y is equal to 2 to the 0. Well, 2 to the 0 is equal to 1. We talked about that already. 2 to the 1 is equal to 2, and 2 squared is equal to 4. What I want to do now is work backwards. And in order to work backwards here, you can see, so this kind of helps us understand why that sort of rule works. You can see that in order to go this way, we end up multiplying by 2. So to go from 1 to 2, I multiplied by 2. To go from 2 to 4, I multiplied by 2. This is an exponential function. This is the common ratio, and that common ratio needs to be consistent throughout. So that's, not a ration, but a ratio. So that's a common ratio. And we should be able to use that common ratio to kind of work backwards. So what do I need to multiply by 2 in order to get 1? Well, we should be able to take 1/2 and multiply by 2. Or if you prefer, if you want to go, if to go down in this table, we're multiplying by 2. If we want to go the other direction, we want to undo that multiplication, so we end up dividing by 2. So 1/2 divided by 2 would give us 1/4. And again, 1/4 times 2 would give us 1/2. So we've got that common ratio there. And again, this is saying that 2 to the negative 2 is equal to 1/4. And just in case you're not sure, that's the same as 1 over 2 squared. So you can see that that rule that we talked about on the previous slide actually does hold up. 2 to the negative 1 here is equal to 1 over 2 half, which is the same as 1 over 2 to the 1. So again, we just take that power with a negative exponent, take the whole power and put it in the denominator, and the exponent becomes positive. All right, let's look at here what happens with 2 to the negative x. So let's, I'm just thinking here where we should start. Maybe we'll start at the very beginning here. So 2 to the negative 2. Sorry, 2 to the negative, so there's my 2, there's the negative, and then the x value here is negative 2. So this is the same as 2 to the 2, negative 2 negative of negative 2 is positive 2, so this would give us an answer 4. This here, 2 to the negative of negative 1, that's going to be the same as 2 to the 1, which is equal to 2. 2 to the negative 0 is going to be just 2 to the 0. Let me write that in. Whoops, I got an extra mark there. 2 to the 0 is just equal to 1. And 2 to the negative 1. So here we have 2 to the negative 1. Again, following this pattern, what are we doing as we go from top to bottom? Well, the common ratio here is a half, or divide by 2 if you want to look at it that way. Multiply by half or divide by 2. So if we're going to take this and divide by 2, 1 divided by 2 should be 1 half, which, as we said earlier, is just 2 to the 1 over 2 to the 1. And same thing here. This 2 to the negative 2, we should take half of a half, which will give us 1/4. So you could just, again, just reiterating that fact where those negative exponents appear, you can just take that whole thing, the whole power, and put it in the denominator. The sign on the exponent will change, but that's it, not the sign on the base. All right, so let's take a minute, maybe pause the video, try these 4 examples and see how you do, and then you can come back and have a look. So hopefully you had a chance to pause the video, give those questions a try. Let's have a look here. We kind of did this one already, I think. So it said to rewrite using positive exponents. There's the positive exponent. 2 cubed is equal to 8. So we get 1/8 there. Same sort of thing here. We have our negative exponent. It's in the denominator. We're going to take that whole power and move it to the numerator. The exponent becomes positive, so 1 over 3 to the negative 2 turns out to just equal to 9. And if you're not sure, you can double check on your calculator to verify we haven't made a mistake here. Here's that example where we have 2 that are negative, a numerator and a denominator with an exponent that's negative. So let's take that 3 to the negative 4. We'll make the exponent positive by putting the whole thing in the denominator. 2 to the negative 3. We'll make the exponent positive by putting the whole power into the numerator. So there's the writing as positive exponents. 2 cubed is 8. 3 to the 4. 3 times 3 is 9, and 9 times 9 would give us 81. I'm sorry, that's a bad looking 8. Let's try that one more time. A little bit too quick. All right, and this one here is a little bit interesting because it's a fraction, but the rules are still the same. We have probably several different ways that we can do this question. So we could do it by taking that whole power, putting it in the denominator, which gets a little bit messy because now we have fractions in fractions. So that's one way. Well, I guess we should keep going with this. When we square a fraction, or have a fraction, the exponent applies to the numerator. So we get 2 to the 4 here. And it also applies to the denominator. Now this is a bit weird and maybe not the easiest kind of method to go about, but here we're dividing. We're dividing a fraction by a fraction. So when we divide by a fraction, we're taking 1 and we're dividing it by a fraction. We multiply by the reciprocal. I think I'm going to stop that right there. So 1 times 3 to the 4 is 3 to the 4, and we would get a 2 to the 4. And then we can evaluate. The other alternative here is to just apply the exponent to both the numerator and the denominator right away. I think it avoids that sort of 1 over part. So we get a 2 to the negative 4. So that negative 4, that exponent of negative 4 applies to both the numerator and the denominator. So 2 to the negative 4 divided by 3 to the negative 4. And now we can just do the same thing we did over in part C. Take that negative exponent, take the power, put it in the denominator, and the exponent becomes positive. And do the same thing with the 3 to the negative 4. There we go. 3 to the 4 is 81. 2 to the 4 is 16, which is really the same answer. These parts are the same here. So All right, and I believe one more set of examples here. All of the examples we've done so far have included some numbers. The same is true for variables. So simplify and rewrite any negative exponents. It looks a little bit messy here, but we have x squared y cubed times xy squared z cubed. Now remember, we can only multiply powers with the same base and simplify. We can still multiply if they don't have the same base, but there's no way to simplify. So I'm going to take this x squared and I'm going to multiply it by x. The understood exponent here is 1. So x squared times x, we have two of them, and multiply one more, we get an x cubed. And then we have y cubed times y squared. Multiplying powers with the same base, keep the base and add the exponent, so we get a y to the 5. And last but not least, there is a z out here. It's cubed, so we'll keep that cubed. All right, let's move on to b here. Here we're dividing powers with the same base, so a squared divided by a to the 5. The rule there is subtract the exponents when we divide, keep the base and subtract the exponents. So 2 minus 5 will be negative 3. And b cubed divided by b, don't forget this is an understood 1. We get b squared. Now again, we were asked to write all exponents as positive exponents. So we take that a to the negative 3 and drop it into the denominator. And when we do that, the exponent becomes positive. All right, and one more, just dealing with powers of powers. Again, this power of 2 on the outside applies to everything on the inside. So we end up squaring the p squared and squaring the q to the 4. So this is going to equal p squared squared. And once you get good at this, you may not have to include all the steps, but it's probably not a bad thing to do from the beginning. And here we'll get q to the 4 squared. And we still have p over here, and we still have q cubed. That's hard to say. All right, p squared squared. When you have powers of powers and we multiply those exponents, I know it's hard to tell whether we multiplied or added there, but here it becomes a little more obvious. Q to the 4 squared. 4 times 2 is 8. So multiply those two, and then we still have p and q cubed. As I said, as you get good at this, you'll be able to do sort of more in one step. I want to break it down so you can see it. P to the 4 times p, we're multiplying powers with the same base, keep the base, add the exponents, and again, the understood exponent here is a 1. And finally, last but not least, q to the 8 times q to the 3, keep the q, add the exponents, 8, 3 gives us 11. So that was an introduction, reminder, review of some exponent laws and how to manage and deal with exponents.